Orange heeft al een paar keer ook gesproken.
1, 2, 1, 2. 1, 2. Is it working? Wonderful. Perfect. Well, thank you very much, everybody, for coming tonight. It's a pleasure to start this experience, which is this distributed meetup. As some of you may know, the exact same thing is starting to happen already right now in Berlin. It's pretty exciting because there will be a lot of floppy things probably happening, and we'll have to deal with them. But it's an experience, and we like it a lot. Before I talk more, I want to show you something. We knew that. Just a second.
Yeah, come. Did you change anything on the settings?
No, I didn't.
Hmm?
I didn't. Apologize for this one. Lovely. Now we can start.
In the Nature 2.0 track of the biggest blockchain hackathon of the world, we will be asking you to build ownerless ecosystems, to build ecosystems that operate towards abundance. We will be asking you to build commons.
People don't have to have ownership over natural resources. It's very interesting to think of them being self-owned, self-aware maybe. And for that, I think we have an interesting mix of technology, ethics, ecology, maybe some philosophy that combines into a nice project called Nature 2.0.
And we are providing the workshops, the masterclasses for you to learn. Together with Dimitry of Ocean Protocol, we designed a 3-layered approach where in 3 meetups we are going to use these new technologies to create ecosystems beneficial for the world. We will be giving you the insights, the hands-on way to work and to build these solutions of tomorrow. It's unimaginable what's going to happen, and you are going to build it.
All right. Wonderful. I will not be speaking a lot more. I'm just your modest moderator for tonight. My name is Max. Very quickly, because I have a few things to share with you before we start. As you could have seen, we have 2 screens, one on your left and one on your right with my name on it. Wonderful. This second screen is enabled by an application called Tinder. No, just kidding. It's called Squiffer. But it's kind of Tinder, but for professionals and for hackathon. So for this purpose, I will enable you to please go to this website. It's called play.squiffer.com. Just open your phone, go on your browser, input play.squiffer.com. You will find a screen which will invite you to input a code. This code is named DECMA, and I heard that this means something very special for Dutch people, so I hope you got the joke. If you didn't, well, too bad. Once you input that code, you will be able to fill up some informations about you, informations about who you are, what you do, what kind of person, and they will ask you to describe yourself a bit. This is all made so that in a while, during the break and after the talks, we will be able to connect. And it basically works just like a normal Tinder app. So for those of you, raise your hands, who ever used Tinder here in the room? 1 person, 2 person, 3 person. That's a very big lie. I believe we have a lot of liars here, but it's all right. So when you have Tinder, you basically swipe on the left or the right based on what you're looking for, and it's basically for you to be able to look for people. So here, for example, I have on my phone Douwe van Dijk, who is the amazing person over there who actually created this app. And of course, I want to connect with him, so I will like. And I see no match, so apparently he didn't like me yet. But hopefully, once he likes me, we are able to connect. You've liked me? Oh, wonderful. My matches. Yes. So if you go on the menu, who is connected yet? Who isn't? There's no Wi-Fi, but there's connection. I'm in 4G connection here. All right. So come and stand here. All right. When you will be able to connect, when you will be able to get a bit of Wi-Fi, so of internet, sorry, we are live streaming here, so the Wi-Fi might be a bit slow. You will be able to arrive on a screen where you can basically swipe left and right. Once you do that, you're able to match with some of the people in the room here, but also some of the people in Berlin. And we can already see that some people already registered, so now you can basically go and try to swipe left or right and try to match with some possible developers. And without further ado, because I'm already way over time, I will give the hands to JP, because this is, as you might know, a 3 layers meetup, and I want him to be able to tell you a bit more about what it is and why we're here tonight and the reason of this meetup to be created. So, Jan-Peter Dominic, please welcome him.
Hi, we are here today to invite you all to participate in the Dutch Xain Hackathon, the biggest blockchain hackathon on the world, and then especially on the Nature 2.0 track. In the Nature 2.0 track, we will be looking for the craziest solutions possible. We want to understand disruption before it happens, and that's why we are creating a lot of content, a lot of workshops for you to explore the unimaginable where you are most passionate about. We think that there are a lot of solutions possible where we're not hindered by technology, but by the way we look at the world. Nature 2.0 started as a paper of Trent McConaughey, who wrote it in June on Medium. And he says Nature 2.0 is a vision of the future, a positive one, where we are going to combine different technologies to come to ecosystems towards abundance. But how can this be, you ask yourselves, ecosystems of abundance in the world of today? Well, that's why we like to look, for example, at the forest, because in nature, entities co-create with each other. Where we humans are used to compete. If you look at the forest, then you have a number of trees and they are connected by a mycelium network, where the big trees help the small trees to get food so that they don't have to become competitors on sunshine or on rainy water. One of the biggest insights for us was, if you are looking for the unimaginable, look at the world of 8.7 million species who have working ecosystems for their housing, for their food, for their energy, for their transportation. And if you look at the ecosystems of animals and other species in nature, then you see that they are not based on ownership, identity like we use it, or on money. And some of them are not even based on scarcity, but on the fact that when entities co-create with each other, you help each other and you get an abundance of resources. This is where we want you to look at, because in the world of today, if you ask a designer, a programmer and an engineer to build something that lasts 1,000 years, they will get that glow in their eyes and start to build. Until the business guy comes in and asks that question, what is the business model? Why are going to people pay for this today? And how can we ensure them paying for it tomorrow? These questions do something with the way we engineer solutions. So if you look, for example, at the way we have engineered our solution for mobility, the car, then from a money perspective, this makes sense. From an engineering point of view, it's a really crappy solution. So if you want to build a mobility service for the world, and you look at cars, even at the peak, only 6% drive. So if you create this mobility service, it would only contain of these 6%. All those cars have spare parts that do not fit in other cars. But if you create this mobility service, then of course, the elements would be the same. We sell cars for one purpose only. But everybody who has played with Lego knows that with a set of modules, you can build any car you want, and maybe even a plane. And if you look online, then you can see that Bugatti and Lego actually did it. They built a Bugatti out of Lego with Lego engines, proving that this modality, model-based approach is really working. But if you are building solutions like this, you're not building a business, you're building a commons, something that has no owners or is owned by everybody. And we already know that in the world of today, like the voluntary fire brigade, or the blood banks, or the community gardens, the WhatsApp neighborhood groups. Intrinsic motivation of people are building blocks to build solutions. Do you know what also has no owners? The big problems of the world. But they, for example, already have some kind of funding. And people who are really intrinsically motivated to work on them. So if this is the starting point for your solution, then you can build solutions that are really unimaginable. And it has been done before. Because in the last year, we hosted the machine-to-machine track. And we had a winning team, Crya, also here in the room. And what they come up with is a proof of concept where they connected blockchain, basically the Xain 2.0 at that moment in alpha, to the software and the hardware of a drone. Because in their solution, if a guy gets lost in the forest, the drone could find them, allocate them, and help them out of the forest, creating a hive mind between the drones. But if you look at the grand narrative behind it, it was much bigger and bigger. Because at this moment, the world is being watched by satellites. That means that if a refugee stream starts to be created, we can see it. What if we solve those problems differently? At the moment we have the Red Cross and they gather 100 million, 200 million, 500 million euros per disaster. And if the people are helped, the money is gone. But what if you create a service of drones, of flying machines that could create a refugee camp and deconstruct it afterwards? Then we use those millions to create services that could help the world. Exciting is this to the next level if you see what the potential of this is. Because what it is showing to us is that a refugee camp is nothing else than an emergent city, a place where a number of people live. In the infrastructure of today, in the buildings of today, we build them and we invest money to, so that the infrastructure, the building can last 30, 40 years. Basically working with the assumption that the world will not change. But is this the case? Because if the world is changing more rapidly, we need new ways of thinking about these kinds of infrastructures. And then, of course, you can take these solutions and start to working on festivals, which are also emergent cities, built on an infrastructure of nothing. Then there is this place where 10,000 people live for 5 days, and it is gone again. So if you create your machine-to-machine ecosystems in this way, you have a completely new way of thinking. You are picking up problems that are important for all the big infrastructure entities, for the entities that finance our life, like pension funds. You can look at it differently because you can take this information and create emergent cities. This is the level of crazy we want to work on with you. One moment. 1 minute. Okay. So this is why we created this meetup, where we're going to explore this kind of solutions, co-creating together, having the technology leaders in today so that you can learn from them and build on them. And of course, after this session, the people of the livestream, please join in our meetup so that you can follow these 3 meetups, but we are adding a lot of additional meetups. So there will be co-creation with universities where we explore the scientific path. We will be looking at different technologies. We will have a focus on AI. Join the meetup and see the additional information. Because changes like this, we can only do together if we build on each other. If you want to become a millionaire, you will be alone and have to fight. But if you want to make the world a better place, there are a lot of friends who are waiting for you to co-create with them, to build on you, to learn from each other. So what we want to do in Nature2.0 is invite you as a friend to co-create and build with us. Thank you very much.
Thank you very much, JP. As you saw, there was a screen with questions, so you can ask your question via the exact same app that you installed. And right now, I think we're ready, and if the Livestream team likes it, we can switch to Berlin, because there is a talk which is happening right now, and oh, it's working. Well, Berlin, if you want to start, this is the moment for you to go ahead. I don't know if it's working, I don't know how it will work, but I think it is on. Yes, wonderful. Well, the speaker you're about to watch is named Dimitry de Jonghe. He's from Ocean Protocol, and, well, watch him.
Okay, so these guys are ready. Hi, I'm Dimitry. I'm from Ocean Protocol. Today we'll be kicking off the first session of Nature 2.0. We call it Plugged In. And for this, we brought a dog and a robot and a few knives, and we're gonna see who's gonna win. I'm gonna lure the dog in. Lure the dog in? That's no, it's not about putting humans or animals against machines. It's about having them co-create something. For this, we have a three-tier approach. One of them is plug your systems into something that's decentralized, autonomous. The second part is have those agents that you now put in there, make them self-owned, maybe self-controlled, make them run on the substrate. And then in the last moment, in the third session, we're going to try to add some intelligence layer on top of it and maybe tie it into legal systems and things like that. So really trying to create an alternative universe that hooks into the physical world. For this, I had to look into a few inspirational things. One of them was a talk about desertification. That's when the edge of the desert becomes larger and larger, and it basically threatens the zone around it. There's a lot of projects trying to avoid this desertification, but it's a huge problem because you have migrations of animals and people, and you basically have less sustainable land. And there's a big growth rate of this, and there's a person called Xain, and he tried a few approaches. In his first try, he was thinking that, well, it's about, he's from South Africa. And in his first try, he was thinking, well, maybe it's the big animals here. And they had a lot of, it was back in the 80s, they had a lot of elephants. And he said, well, we have to reduce the amount of elephants in order for them not to trample the land. So we killed about 40,000 elephants under approval of the local government and all of that, and nothing happened. So that was just a loss. And he started, well, he was devastated, of course, but he didn't give up and started realizing that in order to make land more fertile, you not only have to invent something that's close to agriculture, but close to natural biological systems, which means that you not only want to have animals that fertilize a place, but you also want to move them along a trail like predators would do. So for this, he designed a recipe that basically, what they call, you could call it planned grazing. So basically you take your cattle, you move it along a grid, but you make sure it doesn't stay at the same place. And this has been implemented in many different types of areas of the world, global areas, and has proven a lot of results. And it's a specific recipe that can tackle this type of behavior. Another thing that's really interesting, and that's a talk you should definitely see, it's about Willy Smits, which is a Dutch guy. And he has a passion for chimpanzees and orangutans, and he went to Borneo because there he saw that there was a huge depletion of these monkeys in the rainforest there. And he noticed that a lot of things happened because poor local economy, a lot of forest fires, just people trying to survive, people having to do this, take these actions, like get rid of the rainforest, take those resources, sell them. But then he managed to do this. He turned, in 8 years, a fully blank, chopped down rainforest into a regenerated primary rainforest. And for this, he had a different plan, a different recipe. And this recipe was very interesting because it has a layered approach, and it's very ecosystem integral. So he started off with getting rid of the forest fires, putting acacia trees as basically fire-resistant borders, and then starting with agriculture. And each layer of the agriculture adds a new layer of soil, a new level of trees and plants. And he did this in multiple phases, but made sure that the local communities always could extract the resources, maintain it, such that they went on the market, had economical value, but also didn't want to do it too fast, so they didn't have to immigrate new people, but really could sustain the local economy. So you have this full circle recipe that makes these things possible. So that got me thinking, well, basically, there's a lot of things happening in the world, and there's a lot of resource depletion, a lot of natural disasters, but they all have different types of local needs. So can we design recipes that can tackle local areas that are integrated with local communities, etc.? And well, since we're from a tech space, we thought, well, how can technology help here? How can we make these recipes be more committal, more community-driven, decentralized, make them into real organizations? Does the recipe need a human, or can it do without a human? So then we went back to maybe a blog post on the Ethereum blog from Stefan Tual, and he was talking about deodants. And deodants it comes from a novel from Carl Schroeder, who's also working now together with Stefan Tual. He's basically a sci-fi author, but he talks about resources that have the same capabilities as humans have. This means that they have a form of intelligence, they can transact on resources, they have legal status, they basically have a sort of personhood or humanhood. So a forest that you would call yourself would be a deodant, but any natural resource. And you can also apply this to infrastructure, like, say, grids, roads, any type of basic human needs, albeit mobility, transport, energy, food, shelter. So these are things that people really need, and it starts to form a form of commons between us. It's something that we all need, and we need to respect the resources that we have for it. So an interesting approach we can take is look at, well, if you go from something that's passive to something that's active and self-actualized, there is this Maslow's pyramid, which talks about what are the basic needs that you have to implement in an agent or a system in order to become more and more human. So I try to apply this, and this is kind of the road we're trying to follow with this Nature2 track. And at the bottom, we have the basic needs: food, resources, warmth. And that means that we have to create something that has sensors. It has eyes, it has ears, but it also has actuators. It can manipulate the resources around it. If we go a level above, you're talking about safety. So safety in a human sense is having the ability to become a legal actor and to make sure that you're protected by a government or a law that's implemented by the government. And then you can go steps above, for example, like empathy, having friends and family, having the ability to have self-esteem, to perform well, to have maybe social responsibilities, and then in the end, a form of intelligence and creativity. So I don't think we'll get here by February, but there is interesting things you can explore on each of these levels. So, and I'm just going to try to give you a bit of a feeling of what we can do right now. So the driving forces, and this is more of the background of my daily job, is about we create decentralized systems. We do it for AI and data ocean protocol. And self-sovereignty is a big part of decentralization because people have control of their own keys, the keys to their own data. With Bitcoin, you have control over your own coins without having to go to a bank. If there is a bank run, then first one wins, last one loses. With Bitcoin, it's more, or any type of other token economy, you always have access to your coins, whether they're valueless or valueful, but you always have access, and you decide what to do with it. Something that's really interesting in this decentralized space is that you can implement incentives in this network. You can reward good behavior, or you can punish bad behavior. You can basically create and assign tokens, you can mint them, and give them to people that you think behave correctly. And there you can implement network objective functions. See how does this system want to evolve. And lastly, we use a lot of cryptography to prove things that happen in the real world. For example, with Bitcoin mining, you would prove that you actually did computation because you have to compute a difficult cryptographic puzzle. You can only do that with so much probability if you spend enough resources. So these can be altogether become really interesting building blocks or paradigm shifts to implement systems that we're talking about. And the system that we're talking about is typically, well, it's a deodant, but if we can implement it as a decentralized autonomous organization. What is this? Well, it's basically, if we look at decentralized systems, these are systems that are unstoppable until the last nodes in the system survive. So these, as long as people are running computers and connect to that system, the software on that system won't die out. It will always commit to that software. So interestingly, if you deploy some code on that network, I'm pretty sure it's going to get executed on that network. Whether you leave, whether you walk away, whether some nodes fail, it will execute. So having that decentralized infrastructure allows us to create something like, you could say, viruses. Viruses that may be spread and are available, but they don't have to be bad viruses. They can also be good viruses. This is just an analogy. So one of the things that I'm thinking of is, what if we have these recipes that basically manage and control natural resources, have them run unstoppable on these substrates, such that if they are incentivizing people like, hey, take care of me, then those people will know they will get paid if there is funds attached to it. So there's a few steps towards this. First of all, we have to connect the physical to the digital. Interlinked is working on digital twins. Xain and Weave are working on decentralized access policies and privacy-preserving computation, and it all fits in having secure hardware connected to the real world. This means that if something happens in the real world, you can prove that it actually happened. You can make sure it happens in the right way and that it gets connected to this unstoppable substrate. Now, you can think of a lot of drones, and I think we have one little robot running around that we can basically add a decentralized access policy to. So this means that the person controlling the drone is assigned by the network. So what does this mean? This means that, well, if you want to define what your natural resource is, then your eyes, your sensors, your ears can be robots. They can basically be sensors, secure hardware, connecting to a smart contract. And if there is that smart contract, if it has some funds in them, it can pay through streaming payments towards those sensors or those robots. So there is like an economy between the ledger, the funds on that ledger, and all the peripheral hardware that manages, gets hired basically by the natural resource. If you look at nature-to-human interactions, it becomes a bit more interesting because it becomes a bit more fuzzy and subjective. I actually found somewhere a project that tries to actually communicate with a plant. Well, it just measures how dry the plant is, and the plant then reports that it's not feeling well and you have to do something. But what's more interesting is that if you look at this decentralized substrate, connecting to it is similar. It's an agent. It's an agent to the system, whether that agent is the actual natural resource governed by a decentralized autonomous organization, or whether it's a bot with a wallet, or whether it's a human with a wallet. They all have wallets. To the system, it doesn't really matter. So now they can start transacting with each other. And this is a very interesting thing, because I don't think it really happened much before, where in history of mankind, where robots actually could own their own funds without a human having to own the funds of the robot. So these agents can go gradually without custodian. So that's a form of self-ownedness in the system. If they then can make decisions by themselves, they can interact with multiple agents according to their likings and their behavior. So I put a bit of pseudocode next to the slides. It would be cool to see these things implemented where two agents interact and exchange resources. Or they maybe play a game. And that's a very interesting thing because people like to play games. And maybe that's the way how we can fuel these initial recipes, these initial decentralized autonomous organizations. Just gamify it. If you look at a human, then the brain consists of two parts. Consists of a rational decision maker and something that just want to play around, an instant gratification monkey. And they have two different types of objectives. This one is just thinking about eating the plate and grab whatever he sees. The other one is thinking about the future, about sustainability, long-term objectives. And then you can connect. People are receptive to these networks that have incentives built in, because they have the ability to create an advantage for themselves, to get more resources, and they would behave themselves according to that network objective. Think about Facebook, give away your data and connect with your friends. Or think about Bitcoin, get money rewards, so buy hardware. So people are actually doing stuff because this digital system gives them an incentive to do so. Of course, if you mal-design, if you wrongly design your system and your objective, then you end up creating something that is sometimes a metaphor to a paperclip optimizer. A paperclip optimizer only has one objective function: create new paperclips. So imagine this paperclip would be, if it's a smart system, then the first thing it would do, it would try to communicate with humans in order to get more compute resources, to become smarter, to outsmart the humans. If it can outsmart the humans, it can take more resources from the humans, so they can create more paperclips until all metal in the earth is gone, and then it has to migrate to another place. But that's basically what's happening with the Bitcoin system and other type of networks. So carefully designing this network objective function, which has to be this fully socially, economically integrated system, is one of the more interesting things that we can do right now. This doesn't mean that you have to be able to code it. At least you have to be able to find what should look like in order to create a harmonious system between all agents. So there's a lot of reward functions you can think of, and with some of them, most of them are zero-sum games. This means that I have A resources, you have B resources. In the end, we're still going to have to get A plus B resources. No new resources created. But there are a few interesting systems or games to play, and maybe we could play one here. Let me see. Without me. So this one is called the dollar auction. So it's very simple, and we can play together. I have, let's say, 20 euros. And we're going to have bits from €1 each. Yeah, so you start with 1 and then €2. And the highest bid has to pay his bid, but it gets the 20 euros. But importantly, the second bidder also has to pay. Right? So I'm putting this for auction. Who's paying €1? Okay. 2 euros. 3 euros. 3 euros there. 4 euros. 4 euros there. So 3 euros still pays. 4 euros you're winning. 5 euros. 5 euros. 6. 6 euros. We have 6 and 5. 7. 8. 15. So I'm already winning. We have 15 plus 8. I'm at 23. I'm winning already. Unfortunately, you guys can't stop overbidding each other. You will go above 20 in order to cut your losses. And the interesting part about this game, it becomes, if you're with 2 people in the room, you can coordinate. You can get my money. But the more people in the room, the less coordination you have, and only one person has to put out a second bid, and you guys are in the loss. You will always try to over. So the more people, the less coordination, the less winnings for you, the more winnings for me. But these are interesting games. People like to play them without thinking about the consequences. If we look at what's happening on the crypto side of things, there we have these, basically, you can set up any type of game or lottery or any type of incentive mechanism, and I listed a few here that I find interesting to explore. One of them are called automated market makers. Think of this as being a resource exchanger, a token for token or tit for tat, and that's always available. It will always, if you want to buy and sell, there's always a robot willing to sell and buy. You can have, interestingly, a very cool bonding curve in there. And a bonding curve is basically setting the price of your token exchange according to a predefined function. So if you say, well, first people that are buying in paying less than the last people, then you have an early mover advantage. You can play with that curve, you can ripple it, you can have different input curves and output curves, extract rent from it, give dividends from it, just by defining a very simple mathematical function and put it to an automated exchange. Secondly, we have coordination games, where we're looking at something called shelling points. A shelling point is where people would automatically converge to. For example, they asked 1,000 New Yorkers, imagine you have a date with somebody, but you forgot time and place, where would you go? And most people would have these, would say, well, 12 at the Grand Station or something, or maybe another famous icon, but they would always, like, that would be a focal point, a shelling point. This is something you find in communities a lot. And a lot of people here are working on something called token-created registries. These are whitelists or blacklists of items that people agree upon in a community that they should be on the whitelist or on the blacklist. I think Weave can tell us more about those things. And then digital scarcity. Digital is there to be replicated, to be viral, to be copied. We started 5 years ago with a company called Ascribe in order to make digital scarcity a reality for protecting, for example, creators that create digital movies or songs or images. And then they can create unique editions out of this. This kind of evolved over time into something that people now call non-fungible tokens. These are tokens that aren't really like currency, they're more like patents, they're more like IP. And then auctions, we just played an interesting auction called the dollar auctions, there's a few others. And then one of my favorites is called radical markets. Radical markets, they're close to liquid democracy, where you basically can delegate your voice or your vote. But by doing so, the power of your vote, if you give it away, if you delegate it, the power goes quadratically down, or according to the square root. And then there is something very interesting, it's called Harburger taxes. And Harburger taxes is a new form, it's not new, but now we can actually build it. It's a form of pricing assets. Imagine you have real estate. And your real estate, you have to pay 10% taxes on that annually. Now, you have to pay 10% taxes on what you value your own real estate. You can set your price, and if you set your price, you're committed to sell at that price. So typically people would put that price out there, but you have to pay taxes on that. So you say, maybe I shouldn't put it that high because I have to pay taxes. So I can choose my own equilibrium point. I think we have these two forces, the taxes pulling my price point down, and then my personal gains pulling it up, and it will create an equilibrium without the market. Normally pricing goes with bid and ask in the market, and you have a spread, but this doesn't require another actor besides myself. So very interesting stuff. There's a lot of cool, smart contracts you can look at. I put two of them here that don't exist yet, and I love to see them. One of them I call the Banksy contract. You buy something, but you don't know if it's going to destroy itself once you buy it. And then the black hole contract, you put money in there, you don't know where the money is going, you don't know what's going to return. Just weird. People might find that interesting. If we then go one step up, so machines can talk to nature, nature can talk to humans, humans can talk to machines, we can exchange resources, we can play games with each other. And now we're going to look at what's legal, what's not, can we defend ourselves? Well, there are a few really interesting projects. One of them is in New Zealand. I don't know if you know, but in New Zealand, rivers have legal status. A river can actually sue in court a human or a corporation. And this is because there's two types of people in New Zealand. You have the Maori, the local tribes, who regard natural resources as humans, as being the same level of humans. And then we have people that just say, well, we just have law. And they had to come together in some point, and that's where they decided to inherit this Maori feeling of natural resources and to put it on the same level as legals. So this is going to be very interesting to see, can we implement this in other places? Can we tie legal status to natural resources? Well, in Dubai, I think it's Dubai, I might, well, somewhere around there. Saudi Arabia, oh yeah, and that's the weird part of it, because yeah, they're not so pro-woman in legal. Yeah, so Sophia got legal status right there. And now there is, in Malta, there is a lot of regulations trying to see, can we create these decentralized autonomous organizations? Can we give them legal status? And here's then the trick. You create a DAO, and gradually you move out the humans and create self-owned, self-conscious agents attached to it that make the decision-making about the funds of the DAO. Now you have controlled funds without human guardian on top of it. So I think maybe in a not so far future we can create interesting systems out of these things. And if we do so, we have to think about what's empathy. I sometimes try to encode empathy in something that I would say it's a knowledge graph. How many minutes? I have 5 more minutes. Plus questions? Okay. Well. Oh. No. I'll just go a bit quicker. So with empathic protocols, I mean that you can estimate what are the wants and the needs of another agent in the system. What if we have our knowledge graphs that says, well, these are the resources that I'm going to need on a daily basis or a monthly basis, and I need this. Well, if you can expose that knowledge graph, albeit through any type of data structure, and then you can normalize it such that I can to how my knowledge graph looks like, and then I can understand how you think. Or at least how it doesn't, on a human level it's going to be tough, but on an agent level it's going to be not so hard to do. So you can basically, you can also inject parts of your knowledge graph in other people's knowledge graphs or other agents' knowledge graphs, which automatically translates into the concepts that they have in their knowledge graph. So this could be a way of agents communicating with each other and respecting the space of their resources. So putting it a bit on a timeline, going from corporations into cooperatives sometimes, not always. We had the DAO, which can burn some money, but sometimes it's really useful. We're exploring these non-human agents that can own resources, but not somebody owning that resource. We can create wallets that nobody can touch, but they basically, the private key is hidden within the hardware. And then we can create AI DAOs. DAOs that are fueled by artificial intelligence. There is not more human decision-making, but machine decision-making in there. So these are really self-owned, self-decisive machines running on this unstoppable substrate. There's one that we are collaborating with, it's called Autonomous. Autonomous, it has a GitHub repo, it's working. It's basically an AI artist. It creates arts. And it puts that art into an auction. And when it sells the art, it gets the money from the humans. And it decides, whether he needs more compute to create new art or just piles up the money somewhere. And with money we mean tokens. So these things aren't too hard to build. There are templates out there how to do this. And then we can create self-driving cars, autonomous machines, self-owning machines. Maybe we can look at mobility in a whole new way. Maybe the car pays the road extracts harbor taxes, self-owning wind farms, what have you. But the cool thing is that in these systems, they're all agents. Nobody knows you're a forest, you're a bot. They're all agents, and they have actions between agents. So for Ocean Protocol, we say, well, in Ocean Protocol, nobody knows you're a data set. Nobody knows you're a machine learning algorithm. You're just an actor in the system. So that's it. I think we have time for questions left, or not. Otherwise, we can just have a beer afterwards. There is. Oh, this is so weird.
All right, my question is, you mentioned actually your Ocean Protocol. What's the technical difference between, for example, Ethereum protocol? Or could you explain with a few words, 2 words, 3 words? Do you using different cryptographic method, different elliptic curve, or what's the essential technical difference?
So, if you're looking at the system that we're building, a layer 2 solution, and we say Ethereum is a layer 1 solution. It's a bare-bone substrate to do decentralized virtual machine, decentralized compute. What we do is we build decentralized data pipelines on top of that. We tap into those processors that are decentralizedly running. We have our native token, but with a different application area. We confine ourselves to giving access to data sets, machine algorithms, having validation on top of that. We're basically on top of a layer 1 solution like Ethereum, but could also be EOS, could also be something else. We just need to have a virtual machine underneath us. It's a protocol. We're using the technology of fat protocols, where you have multiple protocols on top of each other. Think about how the internet stack looks like. You have this OSI stack. At the bottom you have hardware, then you have the IP language, then you have sessions, you have applications. But each of them have their own protocol, and you abstract yourself such that you don't need to know the details about the underlying protocol.
Could you explain how those self-owned agents can solve the environmental problems in the first slides that you mentioned?
Yeah, so it has to start with humans. So I think, I would say, let's think about those recipes, where a local community expresses their wants and needs and saying, we have a problem. And then they would basically create something like a corporation or something like a cooperative and need funds. So it's all about governing those funds. And now we have 2 options. We can either have a human decide on where the funds go, or we can have a full feedback mechanism, a machine that's basically dispensing rewards according to KPI. You trust the mathematics and the rules.
Okay, so quick question. The mathematics and the rules, when applied to engineering, they follow a linear logic. Nature has another logic. How are we going to deal with this?
So I don't think that's true. I would take a systems theory approach here, where you basically try to model a system, you measure a system, and have a control loop around that.
But for measuring a system, you have to define it and to set.
Yep.
Nature has no boundaries. Nature has no boundaries.
No, but those local areas have
And it's hard to define them, to encapsulate them.
But that doesn't stop people of doing stuff.
And they are damaging them because of that. Because the whole.
Exactly. So if we have better and larger feedback systems, where not everything is looked at as an externality, then what you're proposing is a collaborative tissue, a unique source of truth that goes around the globe. So that's kind of what that substrate means.
Yeah, but exactly this, and this doesn't follow a linear logic of construction. For example, one of the problems here is the very act of defining the problem.
That's a start, but it's also about governing the objective function. You don't want to make it sensitive to initial. You want to have long-term and short-term feedback cycles. You want to have data capturing in the middle. You really have to look at this as a cyber-physical system who have been designed in the past, but not at a scale that we can do right now. So and that's a very good point, and you need people that think more broadly than just looking at the specific subdomain problem. But yeah. Hello? Hello? I would say in order for these things to become widely deployed and a commodity, then they have to be large scale developed. That's one thing. What we're looking at is an experimental sandbox, a place to explore and play with these new types of market mechanisms, with these new types of human-machine, human nature. So we're building basically a toolkit. We're not deploying the entire worldwide thing. We're building a toolkit that not only consists of technology, but also thinks about ethics, about feedback systems, philosophy, all these things behind it. Start somewhere. So I'm thinking that one of the most interesting places to start with is something more experimental, something more in the art sphere, something where you create a narrative rather than a solution. Because you need a lot of people, you need to commoditize all this knowledge and hardware and software and what have you in order to deploy this at a large scale. So what we're proposing here is, of course, an experimental sandbox for people to play with and implement with.
So from what I understand, Ocean is kind of a decentralized marketplace for data. How does all of this, I guess, Nature 2.0 stuff that you're working on fit in with the broader vision of Ocean?
Well, with Ocean we have a few objectives, and one of the main objectives is incentivizing the commons. And the commons, instead of open free data and knowledge and machine learning and artificial intelligence, break open the silos and have them not the personal private data, but the thing that should be shared with the world, made that commonized. So that's where we basically have a clear interface. And also if these systems, if we want to play with this Nature 2.0, there's going to be a lot of data capturing, there's going to be a lot of machine learning attached to it to make that decision making on point. We design incentives to make stuff for free or to fund projects that don't have capitalistic interest. So that's a few of those building blocks that we're also employing at the Ocean Protocol side.
Cool, makes sense.
Yeah, I think we have time for a question if someone wants to ask.
Yeah, in the one of your last slides, you put this memo about the Skynet with this decentralized artificial intelligence, autonomous organizations. Like, where would you put the limit of the objective of these DAOs? No, like for example, building or for example these autonomous, no, like where is the limit where this artificial intelligence would say, I won't manipulate the price, or I would use it in the right way, or where's that boundary? Like?
That's a very, very difficult question to answer. I mean, you always want to have like at least a pause button, or maybe a stop and kill button, as a human, protecting your resources and your species. Maybe the nature is thinking, where is the limit of the humans from that side? I think looking at stability in systems, that's something you can measure, where it say that the amount of resources flowing in equals the amount of resources going out. The system is self-sustaining because it's self-dependent. So that would be interesting points to follow. Of course, things can go malicious, but then they need to have a form of governance. They need to have feedback systems, complex task, but interesting to think about.
Thank you.
Yeah. Sure.
We should have a little break now to fix the connection. After the break, Rapid Beer is not here. We've got 4 friends and community speaking here. Short input, ask questions, and we're going at the end to showcase where Marcus is.
Hi again. So this marks the end of Dimitri's talk with his questions and answers. I'm very sorry you couldn't because there was no flow. There is a screen, however, on your right here where you can ask some questions. You can, you will be able to ask some questions in the next talks as well. Right now it's time to brief and to have some beers and burgers and pizzas. We will be back at 8:10. Please don't be late. In the meantime, as you can see right now, the Tinder is back on. So please use the nice network of outside this room and log in Squiffer and start mingling. And also have a brief, have a cigarette, have a joint, have whatever you like. And we'll be back soon. Take care, everyone. You can get. Hello, hello. We will start again. Yeah. So, welcome back. Welcome back, everybody. I think we can now have not me again. Yes, wonderful, perfect. Well, I hope you had a nice break, a nice brief, a nice beer. And now we are getting ready for our next guest, who is from Interlinked. His name is Carsten Stöcker. Hope I pronounced it right. And yeah, well, without further ado, Carsten.
Yeah, thank you. Welcome, everybody. It's a big honor being here today at the Nature 2.0 meetup. And we will talk about, let's say, a very foundation of Nature 2.0 and what we call intrinsic identity. Yeah? I think because you can say, okay, today when we talk about identity, we think about our passports, we think about our identity card. On identity card, we have our name, our birthday, our physical address. So when we move to different location, it's kind of outdated already as a digital identity, the identity card. Then we have government databases with social security numbers. Then we have corporate databases, Facebook, Google, Amazon. So they all have our digital identity everywhere. They know more about each other. They tag us as a human. They give us a number. They give us a hash code. They give us something to kind of to control who we are. And we would like kind of to put this upside down, and that's what we call an intrinsic identity. And yeah, we give a little bit of introduction what it means. So we like to go back to Leonardo da Vinci, because we like what he said in terms of enlightenment, to develop a complete mind, study the art of science, study the science of art, learn how to see. Realize that everything connects with everything else in the cyber-physical world. So at his time, cyber-physical world didn't exist, but in this time, a big enlightenment, the biggest enlightenment of his time was duality. Duality in terms of science and art. So you learn in science, you learn in art, you combine the two. So 1 + 1 is much more than 2. You got a lot of intersection, you convolute science and art and get much, much more new insights. And yeah, so what's our biggest duality today, in today's world? And our biggest duality is the physical-digital duality. The cyber-physical duality, the digital-physical duality, however you call it. But suddenly, so we are all living in a physical world. It's our machines, our iPhones, our sensors, our body parts, our heart, our hands, our objects. Everything's in the physical world. And suddenly we have a digital representation, a digital world. So you can call it digital identity, digital twin. It's basically a digital representation of a real-life physical or biological object. And there's so much truth and so much enlightenment, so much opportunity, so much risk to be discovered in this duality. And that's what we're talking about. So with Interlinked, we are looking at the fourth industrial revolution. So that's what we do on the commercial side. And in the fourth industrial revolution, so we have a huge variety of new technologies. We have machine learning, we have drones, we have autonomous cars, we have blockchain, we have CRISPR-Cas, gene editing, we have a shitload of different technologies. All these technologies are now at a tipping point, first time in human history, and they're all at a tipping point as a super accelerating exponential pace to be deployed, to be adopted, kind of to interact with the so with our industrial domains, with our personal lives. And this is a tsunami of change and disruption that's about to hit us. No one is prepared, we'll see what it means. So it can be for the good of society, but there are also very big risks associated to it. So Industry 4.0, it's unavoidable, and the foundational layer is identity. So that's what we do. So we focus on identity, on digital twinning. And so we see it, let's say, as a next step. So when we kind of have Industry 4.0, industrialized our industrial domains, or digitized industrial domains, personal life, then for us the next step is kind of the symbiosis of biological and machine agents, and that's what we nicely got introduced in terms of Nature 2.0 tonight. So what is an agent? So I like kind of to give it a definition. It's a textbook definition. So an agent is anything that can be viewed as having perceptors to perceive the environment, and having effectors to kind of to react with an environment. And they are kind of humans, living organisms, ants and bees. So you can see this as biological agents. They have eyes, ears, organs for sensors, and hands and legs for effectors. They're basically an agent. So in addition, there are robotic agents, like the roboters, the KUKA roboters, for example, our cars, robotic agents, and software agents. So we are primarily looking into combining digital identity with software agents. That's what we do. In addition to, there are also autonomous agents. So when the agents suddenly make autonomous decisions, they only get a purpose, maybe from a human, from another agent, or for another agent. And then suddenly they start to interact in a commercial, in a physical way, in a service way with the environment. And yeah, so what's kind of needed, so kind of what we call an intrinsic identity that's fully protected, fully controlled by the entity and not controlled by someone else. Yeah, technically speaking, so we have our digital twin, a digital representation of a physical or biological object. So this is kind of, let's say, a little bit of passive, an identifier and a lot of data. Now it's being combined with an agent, and suddenly kind of we activate the entire identity in the digital world, because suddenly via the agent, my digital me, a digital twin of a car, a digital twin of a weather station can start to transact with other physical or biological entities. What is an agent? Let's learn from nature. So we pretty much like biological agents, the ants. And what's very important, ants have an identity. An intrinsic identity is exactly what we talk about, and they have no fake ID. So ants don't have a central numbering system, so there's not a human putting numbers on top of the ants and putting them in an SAP system, and the SAP system is controlling the entire ant colony. So it's called ant colony optimization, and it's primarily built upon a very simple peer-to-peer communication protocol. So in the case of ants, it's their odor, it's pheromone-based kind of communication. And it's indirect communication, and ants can communicate among each other, they can protect the entire colony, they can help each other to find scarce resources such as water. The desert ants, they cooperate among each other. Sometimes it's called the Internet in the ant world when they cooperate among each other. And with this cooperation, they can find scarce resources such as water. They use kind of the water as even kind of money, operations costs. They optimize this to ensure the entire colony is protected, fed, and grown. And now look what happens when humans study ants, and now we look what happens when humans study bees to learn how they communicate to build better agents. So what the humans basically do, they basically put numbers on top of the bees. A fully numbered bee colony, or beehive, and that's pretty interesting. By putting the numbers, you can learn how the bees, with their intrinsic identity, because bees cannot kind of read and number and label themselves, but they have the intrinsic identity. They have a communication protocol. And it's pretty interesting. It's called the dance floor. So in a beehive, there's kind of a dance floor. A bee that found a scarce resource is flying into the hive, kind of doing the dance communication. Other bees observe the dance and kind of interpret it, and then they know, okay, where to find the next flower for feeding the beehive. And it's pretty interesting. They can do it with, without a central numbering system. They can optimize resources, they can find resources, they can communicate among each other, and that's kind of the bee agent system, so where you can learn from nature how it works. Fully intrinsic identities, no central numbering. Only when humans want to study them, then people put numbers on top of bees. So in this world, we have 10 to the power of 18 different bugs and insects on the world. So it's pretty big. And now you would like to think about what happens when IoT comes in and when IoT is getting a little bit of intelligence, and draw a bit of comparison. That's a comparison that we call animal intelligence versus IoT intelligence at the edge. So I have an embedded device, which is a let's say, a microcontroller, a little bit of computing device. I give the device some memory. I put some neural network into the device to give it some kind of, let's say, artificial machine learning intelligence. And when you compare this, that's interesting. You have the jellyfish, the lobster, the ant, the bee. You have neurons, you have synapses. And then you find out for kind of, let's say, an indirect communication system, peer-to-peer among agents, you need at least 250 megabyte of RAM plus the neural network. And when you would like to go, let's say, to more direct communication system, peer-to-peer among the participants, you have to put, let's say, almost 1 gigabyte of memory in such a thing. A lot of people are pushing IoT towards this. Today, you can kind of simulate a neural network in software running on top of a microcontroller. You don't have the kind of technology available to put neural networks into IoT devices, neural networks that can communicate among each other, that have the energy resources and the cost constraints, but it's not so far distant future, so people will be able to put neural networks in edge devices and then have intelligence, and suddenly even small IoT objects can start communicate, can do peer-to-peer among each other. We heard about the river, Wanagui River in New Zealand. The Wanagui River is kind of a people, so we heard it from Dimitry. So it's kind of, it gets its personhood. And I think that's a little bit of an illustration. So what does it mean in terms of Nature 2.0? So we have the forest, the Wanagui River. It's a kind of, let's say, piece of nature. So in addition, we give the forest a personhood agent. And when suddenly the forest has kind of, let's say, biodiversity problem, or it's kind of migrating species from one forest to the other forest, there's a little bit of interconnection, or there's a fire in the forest, a little bit of forest got destroyed, then the personhood agent has the ability kind of to do a transaction with a seed, with a swarm of seed planting drones, and then the drones can repair it. And that's kind of, let's say, one analogy how the symbiosis of biology, the forest, and technology, machines, can form a symbiosis to kind of to protect the integrity of our planet, to protect nature, and give us a wealthy, naturally rich, forest and natural environment to live in. So a couple of requirements in the digital world in terms of intrinsic identity. So you would like to have something similar in the physical world, no central numbering system, identity full controlled by the entity, by a human, by a machine. So you would like to use what we call a proof of uniqueness. So we have our fingerprint, our iris, our DNA. So you would like to have this really truly unique proof of uniqueness. We would like to use this to connect to the digital world, so that my digital me, my digital twin, can kind of check in a challenge response dialogue whether I authenticate myself against the digital twin, my digital me, and the digital me is proving my uniqueness, proving that I am I with my fingerprint, my iris, my DNA, and then I get access to my digital me and no one else. I think that's the ultimate goal. That's what we call intrinsic identity, and that's kind of what we develop for Nature 2.0. How do we do this? So typically, I think we hear from Xain about access control agents. So you can say, okay, it's called a simple reflex agent. Like you get an authentication, and then the authentication is being processed. So we have here Alice and Bob, and then the agent is perceiving in the world. So how does what the world looks like now? It gets information about Bob, and then goes kind of, let's say, what action should I take? Checking in terms of an access control, validates, is this really Bob? And then an action is being triggered, and then Bob can do some stuff, and that's kind of an access control agent. So what we are doing, so we are combining this with technology called multi-party computation. That's pretty interesting, because you have your fingerprint, you have a private key, you have your iris scan, you have this information, you shred this information, you store it in an encrypted form, shredded pieces in, let's say, 3 different multi-party computation nodes. That's fantastic, because if it's stored there, no one can just steal it. If you steal one node or the entire network, nothing happens, is fully encrypted. And that's extremely nice, because when I then authenticate myself as Bob, then there's a challenge-response game going on. It can be simple fingerprint, iris scan. It can be a so-called physical unclonal function integrated in an integrated circuit. So the puff agents, the authentication agents, kind of checking am I, is Bob really Bob, and then taking action, triggering something to the effector, and giving access to a digital twin, digital me, its data, resources, connected sensors, and that's what we're basically doing. We also have a three-layered approach with blockchain, kind of to have verifiability in terms of identity, and a little bit of and the storage layer, decentralized storage layer, and the protocol layer with the authentication, the MPC, and an application agent layer for all the peer-to-peer and multi-agent transactions and communications going on. That's what we do at Interlinked, and we are kind of also looking forward in terms of Nature 2.0 to engage with other teams, with other hackathon-minded people to continue developing intrinsic identity, and we usually provide then, let's say, individual support, because some of the stuff is good developed, some other stuff is a little bit experimental, but we provide some stuff to support to engage with teams to build intrinsic identity for Nature 2.0 and for a better world. Thank you.
Well, I believe they are late in Berlin, so if you have questions, please raise hand. Not all at the same time. We will not be able to handle all.
No, there are always questions. Otherwise, we pick people to answer, to ask some questions. Yeah. You must have a question.
No?
Huh?
No, you don't. All right. Well, thank you very much then.
Good.
Thank you.
Yeah,
we will wait for Berlin then.
Yeah. Thanks for having me, and enjoy the rest of the evening.
Yeah, I have less time, so I will have to show you. This is one of our access control agents, which have bring the gap between the environment and the agents. And the next point, this is the puff authentication. This is in our case the way that the forest can identify for other agents that it is the forest it seems to be. And yeah, this is our short architecture we want to explain. So we have the application layer with the agent spawns, we have the digital twin in the identity and protocol layer, and at the end we have the blockchain layer, which is needed for their real identity. And this is Interlinked, and we hope to build this kind of infrastructure with you together. And therefore, it's missing one slide. Therefore, we have some examples. You may connect to me or to the team members from me that we can build this kind of infrastructure for the Nature 2.0 and the digital swarms in the future. Thanks for listening, and I'm happy to hear questions from you. Okay, then speak to me afterwards or whatever. Next one.
So while we are looking for the right presentation, I have semi-good news, I think. So whoever has been lured here tonight to see the wonderful Trinidad Fiedler, it is not me. My name is actually Nick, and I'm as well working for Xain, and equally competent, I think, to present what we at Xain currently do and what we have in mind. So I think we're set to go. So I'm going to talk about us, what we do in general, and funnily enough, we recently have drawn an analogy to biology, which is really as matching as it kind of could be. So Xain itself, it stands for the Expandable AI Network, and this is basically distributed around the idea that we started off as a research project from Oxford University and Imperial College to look into something we call distributed intelligence, or we didn't make up the term, it has been there before, but this is basically our origin. And while doing so, we discovered that we have to solve some other topics on the way there, one of them being access control, or rather the proper access control solution, which can be distributed amongst multiple parties which don't necessarily know each other in depth. So what I really want to point out at this stage is the second last point, that we have created a partnership with Infineon, which is becoming important later in the talk. So these are our founders, three wonderful people, highly clever, I would say. So Live is our CEO. He and Michael met at Imperial College, where Michael actually has been his PhD father, and Michael has now laid down his professorship at Imperial College, mostly to join Xain full-time as CTO. And then we have Felix. Felix is a computer scientist, and he and Live met at Daimler. So much about the facts. And now, what do we actually do? So Xain is all about giving enterprises the ability to interchange data. But not only data, but also resources and knowledge. So these are basically the three paradigms we build around them, and we enable enterprises to do so with our own technology, which is called Frost. It's down here. So Frost basically is a domain-specific language we developed over the course of the last year and a half, which is an access control language, and it allows you to create really fine-grained policies. So I could, for example, say, I, Nick, create a policy which has a couple of conditions. Such conditions could be that my wonderful colleague Leah, which is also here tonight, there she is, I could create a policy stating that Leah is allowed to access my car in a predefined time frame, maybe on a certain date, if she transfers me a certain amount of money, and also she only has a 2-time access because she said she only wants to drive somewhere, and I'm saying, okay, that's more than enough. If she wants more, then she has to pay me another $5 or so. So all this is possible with Frost, and Frost is basically mathematically proven and deterministic language, which results in a couple of security aspects. I'm happy to talk in a one-on-one session or later in a shorter session. So then we have our own consensus algorithm, which is called proof of kernel work. I'm going to talk about it in a second. And basically, we are designed for an IoT world, which comes from the proof of kernel work. So proof of kernel work, is, as the name says, has something to do with proof of work. It's only a slimmed down version of the proof of work. So what we actually do is we select a committee, which with a function which is called cryptographic partitioning. So for all the engineers in the room, whenever I say random, I get the same question: how can it be random? So I am an engineer, but no computer scientist or so I can't tell you exactly how it works. But I've shown the yellow paper to a couple of people and got them in touch with our engineers. And after I did that, they all said, okay, that's random enough. So our now randomly selected subset of nodes starts mining. Starts the mining process, the winner gets selected, and then we start all over again. But this basically allows us to keep the level of difficulty for the actual puzzle really low, which results in a high energy efficiency and also some scalability advantages over proof of work. So what we are currently building, and why I said in the beginning that I think what the analogy we recently drew is perfectly matching for tonight's topic, is Nature2.0, but in a digitized way. So we created, let's call it the naming for what we have in mind, which is leveled in 5 levels. So on the bottom level we have habitants. So habitants could be me as a private individual, but we're not targeting these at the moment, but maybe some IoT devices, maybe some data sets. This is basically the lowest level. Where does the data come from? And then we have an interesting scenario, and we as Xain AG, we are basically building solutions for enterprises, and these are habitats. So on habitat level, we have Enterprise 1, which has data, and we have Enterprise 2, which also has data, or might have an urge to get data from Enterprise 1. So currently there is no proper solution for them to actually exchange this data for maybe real-life data streaming of IoT data, because there is, in general, no such thing as sufficient trust between enterprises to build on a common database and be sure that only the agreed on data can be accessed. So what we right now as Xain AG do is we build biotopes, and these biotopes basically combine two enterprises or maybe more enterprises, but a known set of parties, and give them the ability to exchange data with each other. This doesn't require third parties or so, but what we actually do is with Frost we give enterprises the ability to access predefined data sets on the databases of the other enterprises. To enforce this on hardware, and maybe this is the closest that we get to also a physical forest, we have created a thing which is called MDEC, and this is the thing I was mentioning in Finland. This is the offspring of our PLC, which we did with Porsche. I'm not going to talk about it in detail since time is running. But basically what the embedded client is something which is embedded on the hardware and allows us to execute such policies. So a basic scenario which I brought to you today is me as the car owner, I create such a policy. I've been talking before. I broadcast this policy to our blockchain network, which is run by Google Kernel. This policy is then distributed to my own car, and then if Leah approaches my car and tries to access the car checks if the policy is valid, and if so, the access can be granted, and all the conditions must be met, of course. This results in pretty basic use cases, the one I've just been describing, or such a thing that I could also delegate this access not only to Leah, but maybe DHL delivery guy. But we also have some more sophisticated use cases. For example, when I want to enable, or when I as a private individual want to start sharing my data with an advertising company, for example, which is then going to make up for part of the recharging process costs. It's only getting more complex, so I'm gonna spare you the technical details at this level. But I'm going to talk about this a bit more. So, besides the actual data access, we are also talking about training access. And training access itself is basically even the density of access you can give is even below the access of reading or writing data, which is you might have the ability to train on a database. And this is hugely important because of one story I'm going to tell you now. So there has been a company called DeepMind, and DeepMind had been collaborating with Google in the past, and DeepMind was able to optimize or to reduce the server cooling costs for Google server centers by up to 40%. Why were they able to do that? Well, because Google has a near infinite amount of server centers, and they have therefore resulting in infinite amount of data. How do these server center, these cooling facilities behave for the server centers? So yeah, I had a lot of data to train on, and I think Dimi is the best person to say that this is correct. The more data you feed into an AI in general, the better it becomes. So if I would take the same approach with, let's say, BMW, we might not see the same result, or we might not see an AI which is developing as fast. So this is why we created the main train access, so that enterprises can collaborate with each other and share or allow other enterprises, machine learning agents, to access their databases, learn on this data, and then go back to their own databases without taking the actual data with them. They're basically learning on some form of metadata, so the data can be reconstructed, but the benefits have been made. And this access, of course, can be sold. We are doing such a thing with, for example, we have developed a product which is created to structure or to process unstructured invoices. So whenever I have usual bills for something I've bought as a company, this would usually go to SAP and be automatically processed. But as soon as I have an invoice from a hotel, for example, where it says Einzelzimmer or a double room or such, then the SAP system wouldn't know what to do with it. So we created a machine learning agent which is basically processing these invoices and giving an estimation where it should belong, which would then be travel expenses. So this is all fun and games, and if I teach that on my German invoice database, this is all working fine. But as soon as I send a a customer to an employee to Japan, for example, my AI wouldn't know what to do with the Japanese invoice. So what I could then do is I would buy a training access of a Japanese company so that my machine learning agent could train on that company's database, could improve and then automatically or semi-automatically process, there would be a check button, the incoming invoices. So the Japanese, it's a win-win situation. The Japanese company would gain some form of value, and the actual company who has the machine learning agent has optimized time. And this also goes into the level of vehicles, for example. So we are currently really intensively thinking about a use case where we combine this AI part with the FROST technology, so the access control technology, regarding the fact that the car itself could maybe recognize the person and could be sure that the person is the one who has right now the ability or the rights to drive the car, to access the car, and then FROST technology as the access control language, and the compiler could come into play and also allow for these functions to actually happen, while there wouldn't be a central server integrated into that system, and this would of course also allow for offline use cases and such. So I've been talking about the analogy to biology, and I've been scheming out 3 levels so far. We had the habitants, we had the habitat, and we had the biotopes. And we have these biotopes, and these biotopes, they are all fun and games. And then we might be building another biotope, which is consisting of 3 other enterprises who want to collaborate with each other and build their own biotope. And at some point we will reach that point that we have multiple biotopes, and these biotopes then start to have the urge to interact with each other, because one biotope understands that another biotope has data that they might want to buy, or might want to buy access to some database to let their machine learning agent train on it. So this is why we actually created the Xain Foundation, which is basically a neutral roof, and this is where we come into the field of an ecosystem. So within this ecosystem, we give different biotopes to connect the dots and to interact with each other and to build fully new solutions. And we actually can go even a level higher, which I haven't displayed here, but above the ecosystem level, we have the biosphere level. And on the biosphere level, we foresee a great interaction with other projects, such as Ocean Protocol, for example, or any other project which would have, wherever I would have the urge to interact with each other. I mean, we are currently working on use cases, how this could work out, how this makes sense, and how we can combine forces. And we have learned today that it's not about diminishing other projects, but rather to grow together. And this would then be the level where we could display that. So I think that's a matching analogy. I've learned that I have no time for questions, but happy to talk to you afterwards, and thank you very much for your time. 2 minutes. Oh, so then I have questions. So.
One question. If anyone would like to ask one question.
Are you building on existing blockchain technology, or is it new?
No, we are building on that work. What's a quick question?
Can you speak loud?
Yeah, I will speak loud. What brings actually the similarity with nature? I mean, only the having the inhabitants, the habitat, the biotope, and then it's just a taxonomy. But what is actually the similarity with nature? This
is fully correct, I would say. I would say this hasn't been planned for weeks. That I'm being here tonight. So that's why I answer your question.
Oh, okay.
All right. So whom do I own the microphone?
Evening, everyone. I think some of you might have came here to see Sebastian.
Yeah, it is happening. Wonderful. Good evening again. Our next speaker is named Sid. There you are.
Great, thank you.
Please don't talk yet. I don't have your thing on. Yeah, you can. This is Sid. He's from Weave.
Hi, everybody. I'm Sid.
This is not yours, right? This is yours, yes. Wonderful. Yeah, go ahead.
Yeah, we can do the, yeah, perfect. Thank you. So everyone, I'm Sid. I'm from Berlin. I'm from a company called Weave. We are a deep tech company, which is somehow building a technology on the paradigms of IoT and blockchain. So the premise of my talk today lies on the foundation of the future we all believe in, a future where we all believe where decentralized, autonomous, machine-to-machine economy would exist. So we've all seen, or we've all read about scenarios where we can expect a hybrid car which is charging using an induction loop while just standing on a red light. Or we can also expect in the future that a logistics container gets paid automatically once it's proved that it's taken the shortest distance, or it had the specified temperature at which the goods had to be carried on. But in order for all these scenarios to happen, there are a couple of fundamental problems which need to be solved in the first place, and this is where we as a technology, or we as a company, are trying to solve. So the premise is that IoT devices are very low resource constrained devices, and they are easily falsifiable and quite easily manipulable. So we need to build a technology where these IoT devices can become these trusted oracles for the future autonomous economy. And we do believe that IoT devices can become data oracles for the future autonomous M2M economy, but the question really is, how can we ensure that truthfulness such that we can realize their full potential? So in order for us to start thinking more on this question, we have to start thinking in terms of what do these devices are generating. So these devices are generating data. But in order for IoT devices to generate data, they need to have some sort of a trusted computational layer at their processor level. So if there is trusted compute at the fundamental layer, you would have trusted data flowing into whatever cloud architectures or blockchains you want these trusted data to be flowing into. And then taking a step back, we need to start then thinking of data as a singular datum, and then how can we modify this data into the new digital asset where we think that this data can be traded as a commodity. So we all have seen business models now erupting with Ocean, with IOTA, to build data marketplaces. But in order for these data marketplaces to exist in the future, we need to start thinking as to how to have trusted data entering these marketplaces in the first place, because there would be no point in trading a commodity where you don't trust its quality. So for instance, in the physical world, when you buy a good or a service, you are somehow ensured of the quality of that good or service. And even if you're not, you know that there is some sort of a regulatory body that you can go to if that good or service doesn't live up to the levels that you expected that good or service to live to. But in the data economy, there is nothing, or there is no architecture in place at the moment where you can actually go, you can complain, or you can basically settle your argument. And it will be difficult to do so because you will have millions of terabytes of data flowing continuously, and you cannot really have some sort of a body trying to regulate those bytes of data. So you need to have trusted computation at the sensor level such that those scenarios do not erupt in the first place, and then you can have a good quality data economy in the future. So we think of data as a value chain. So while the data is emanating from the sensor level, we need some sort of a secure hardware architecture such that the data can be harvested securely. Then secondly, we need some sort of a computational layer where the data is processed. Then, of course, once the data has been processed, it has to be communicated to a cloud architecture, to a blockchain layer. And then there needs to be some sort of an inspection of the data, that the data which was processed and was harvested was done in the manner where it can become a digital tradable commodity. And then finally, then the data is transferred to that blockchain or their cloud layer where it can become a commodity and be traded by by us, by nature, by self autonomous agents in the future. So this is sort of a technology stack we at Weave are building. So we build on the ARM trust zones, which is sort of a hardware extension of the ARM chipset, a trusted execution environment enabled operating system, which allows us to segregate the normal processing with the secure processing. I'll dive a bit more deeper into that in the next slide. But if you look at the top, you can see that this is how we analogously use data from the harvesting to the processing. Then we use a secure communication protocol called the MQ telemetry transport protocol, but just modifying a little bit specifically for IoT data, because with these many millions of bytes of data flowing in the future, you need a low latency, high throughput communication protocol, and which is why we have added an S in the traditional MQTT protocol, which has been used since the early 2005 or 2007s in the IoT domain, but it didn't have the security or the high throughput which you would require for the future autonomous economy. And then we need some sort of a proof system, which we call the testimony. And the testimony basically is a technology which will enable to take continuous snapshots at the processor level. So if you can take continuous snapshots at the processor level, you will always have something to refer back to in those time periods while those snapshots were taken. So if, for instance, if there is an argument in the future, you can always refer back to the snapshot at the processor level to see where or what went wrong, and then try and settle the argument. And then, of course, you have the blockchain layer where you can settle transaction or settle values, basically, a fair exchange protocol, use cryptoeconomic incentives, tokenize the data, and then you can have an AI or a machine learning layer on top where you analyze the data, make algorithms, start with new business models, basically. Yeah. So this is how we believe that fundamentally we need to start thinking more at the trusted compute level, where the data which is generated at the sensor level has to be attested, has to be validated, and securely communicated to the blockchain layer, to the cloud layer, and only then data can realize its potential of becoming this digital tradable asset. Sorry, something moving around. Okay. And then we can build new business models on top of that. So this is a brief architecture of how the operating system we are devising looks like. So you have the normal operating system on this side, and then you have the secure OS. So the secure OS is primarily for storing your cryptographic keys, storing your cryptographic material, which can be used for signing smart contracts, identifying an IoT device, and a lot of things which you wouldn't want stolen, your wallet address. So a lot of those things which you wouldn't want stolen if the device is hacked. So even if it's hacked, your secure material remains safe, and basically you can prevent. So it's also leading back a bit to game theory. So you do not give the incentives to the people who want to hack these small devices for your secure material, because if you have some sort of a precautionary technology, they wouldn't want to invest a lot of time to hack it in the first place. But the problem right now, it's very easy to, you can basically remote wire an IoT device in $5. There was an experiment by some university, and they did that. So it's quite easy at the moment, so you need some sort of a very secure technology to stop that from happening in the future. So coming back to how we would like to contribute to the Nature 2.0 project, so providing some SDKs, a secure Ethereum wallet, of course the communication protocol MQTTS, which would enable a secure boot process for these devices, and then just seeing that how we can empower this new future of providing a secure self-driven or self-identity-driven autonomous economy in the future. So this is basically what I was describing a little bit, that the testimony takes snapshots or continuous snapshots of the micro instructions, which is something where you can then refer back to and see if the program was executed in the way which you had programmed it in the first place to do so, basically. So just a brief use case scenario. This is a use case we are actually discussing with a German automobile company. And it's a very simple use case. So usually the logistics or the fleet drivers, the truck drivers, they get some sort of a card where they can take it and use it to pay for the fuel which they get the truck fueled for, and basically there's lots of fraud, fuel frauds possible in this scenario, because, for instance, the driver can fuel the truck for 900 liters and pay or use the card for 1,000, but then get the extra 100 somewhere else, and then, I don't know, sell it, get some money, or just fuel it in a different truck, but use this card to pay for it. All right, 1 minute. So there's lots of fuel fraud problems possible here. So we've sort of talked with this company as a proof of concept as to that if we do have the VivOS in the truck installed, the driver can then sign the transaction with his identity. The fuel station knows that this is the exact truck the fuel flew into. And the driver has to, or the truck itself will record that 1,000 liters flew into the truck, and this is only when, only when 1,000 liters flows in the truck, the truck's wallet automatically then pays to the fuel station. So the cases of doing fraud from the driver's side go way less compared to the older scenario, basically. Yeah, just a brief description of some partner companies. I think Interlinked should also be there. Can't see it at the moment, but it should be there as well. Huh? Oh, it's Spherity. Yeah, Spherity is there. So yeah, it's a growing ecosystem in Berlin itself, which is quite cool. I'm happy to reach out to some Dutch blockchain companies as well. Yeah, thank you all. That's the GitHub repo if you guys want to check it out. It's pretty cool. Thank you. Thank you so much.
Thank you very much. Thank you very much, Sid. It was a pleasure. And now for our last talk, which will not be here, but in Berlin. If we can switch the live stream, I believe they are ready already over there. Yes, and they are just waiting for my signal. So that's the moment to take a picture, by the way. No, just kidding. All right, they have my signal, so it will start soon.
IoT, crypto IoT level, your toaster would pay off these gambling bets to the ice cream truck, and so all these things are possible actually.
Okay, I'm taking over again. We have the last person coming here, and then we can have a Q&A. Marcus, are you ready?
All set.
Okay, perfect. You have to understand, it's like we try to do the parallel in Amsterdam. And give us feedback on how stressful this meetup was, yeah?
No, it's no short. From the beginning? There we go. I think you were confused by my title slide. Because it's a confusing title slide. Blockchain robotic AI oracles in the service of the cybernetic forest. Just string together buzzwords like that. Am I being ironic? Maybe. So thank you to Jan Peter for sharing his introductory video and talk to give me license to be a little crazy. This is also not a typo. This is the year 20,118. So there's a bit of a story behind this so-called typo in Ocean Protocol, which I'm a member of as well. We have metadata for our data assets, and I was looking over some of this metadata. It's a JSON file, and someone had accidentally typed this number, and I was really, it bothered me. I was thinking about it as I was continuing over the next few weeks. I left it there just as a reminder. And I was thinking this year, so maybe in 20,000 years, I was just thinking about, this is a very distant year in terms of a human existence, but in terms of a geological existence, in terms of evolution of life forms, geological timespans, it's actually nothing. So I'm going to be discussing a little bit about sustainability, and this might, let's say, provide some context. So first, very basic premise, technology advances. I'm keeping my premises very simple and uncontroversial. So Bitcoin, robotics, gene therapy. In this room, we might have a bit of a limited experience, and we're also not experts in all of these different scientific fields, but there are many things happening very quickly at an unprecedented rate, you can say as well. And the second thing is that ecosystems are in danger, in grave danger. So this is a satellite image of the Amazon rainforest in the year 1975, taken by Landsat. On the right side, we see 2012. So quite a drastic change. Another point is population is controlled by demographics, and demographics are sort of unstoppable in some way. And this will have an impact in our lifetime, in the lives of our children and grandchildren. So sustainability, to meet the needs of the present without compromising the ability of future generations to meet their own needs, 1987 defined. So actually quite recently that we started thinking about sustainability in a serious way. Last month, go to the IPCC website, you'll see a special report released. If you remember back before the media was occupied by other things, which I won't get into here, we actually were thinking a little bit about climate change. What happened to that? We discussed during the Paris report, we saw we need to limit quite below 2 degrees Celsius. It wasn't actually defined there. Now it's becoming clear, the special report, 1.5 C is the limit. Let's stick to that. Unfortunately, we need to achieve net zero CO2 in 15 years. We have already, even at 1.5, multiple compound climate-related risks, and they will fall disproportionately on poor and vulnerable. Coral reef coverage declines by 79%. That's sort of like almost best case scenario. So that's depressing. So technology, climate change, is there a way to move forward? Can we skip this scenario? Maybe. Maybe that's a bit of motivation for the hackathon. So, is this Nature 2.0 or is this? Which one? We don't know. So, now to get a bit technical, I'm going to review 2 projects which I've been involved in, which form inspiration for a new project. So the first project is this robotic vehicle. So what I would like to say with this premise is that robotics is possible for the general public, let's say. So you don't need to be a robotics expert. You can. This robotic, this is I'll just give some background, I guess, is an autonomously driving vehicle running a deep learning network. And it is able to follow a track. And let's skip the video, we can show it later. The other major innovation is these computers on a board. So Raspberry Pi, Arduino, there are many other variants of this. 35 euros, you can get a Raspberry Pi, you have a computer. You can do a lot with that computer. You can run a deep learning network. Artificial intelligence also accessible for the general public, more so than before. We have the deep learning revolution. where we see amazing performance in image classification, for example, made possible by deep learning. And this will become more accessible. So Google has many thousands of AI agents in their processes currently, and that will only increase. These AI agents, or let's say components, if you want to be a bit less ambitious maybe, these will be modular. They will be able to, you might be able to drag and drop them onto a graphical user interface. You might be able to very easily train and deploy artificial intelligence agents. So this was the video. So this is just one frame of the video, but in this project for this robocar, this is what the car sees. This is the camera of the car, so very pixelated. And what I've overlaid is the saliency, which is what that network is currently paying attention to. So we're actually reading the mind in some way of a deep learning network. So oftentimes people will say deep learning is so complicated we don't actually know what's going on inside of them. This is a way to get inside and see what is currently being activated inside this network. So you can use this to diagnose different errors of the network. So then we also have blockchain. Now we get to another cool project in Berlin, run by TerraZero. So this is an art project. So TerraZero is really about changing the world, about realizing these cybernetic forests, these agents coexisting with nature. And of course that's a very ambitious target. So they wanted to hack on a smaller subset of that, and therefore they actually, this is the project, so this is the flower token project. So we see 100 flowers. Each flower is an Ethereum ERC721 token. So you're able to own this token, which gives you the right to this flower, so you can take it out if you'd like, or you can trade it and sell it. So I actually bought 2 of them. I sold one, so I made, and then Ethereum crashed, and I was happy because I basically made 0, so I broke even. But it's an art project, so that's also what I love about this project. It's an art project. So again, from Jan Pita, who cares about the business model, just hack. Okay, so robotic AI blockchain oracles. Does it equal Nature 2.0? Maybe. I don't know. Is this Nature 2.0? Maybe. I don't know. Maybe this is so. But what for me this means is I want to take what I've just presented as I've started a new project. So already thinking ahead to the hackathon, I just want to start hacking. So in my apartment I have a bunch of plants. I have 10 plants. I've built a linear array, or a slide, like it's just a slide. So then the idea is that this is a stepper motor, and this will pull this slider back and forth, and therefore be able to look at each flower. It's not a flower, it's actually, I couldn't find any flowers in the store, so I bought basil and oregano. So it will be able to slide across, and it also has a second axis, a servo motor, so we'll be able to look, first of all, down, and it will be able to hopefully classify how many plants are there, what's their size, what's their status, and then also look up and check out, okay, where am I, what type of flowers is this, so I can actually do the data labeling with the camera. So that's going to be interesting. That's one of the goals I have, is just use optical character recognition to collect the label of the data, so, or the plant, so what is the plant, and I'll just hand write, maybe that'll work, hand write how tall is the plant, so just so I need to give it some hand labels, of course. So, yeah, this is from this morning, basically. So there's a GitHub repo on Nature2, which is a GitHub organization. Let's skip that. So please go to Nature2 Plant Not Plant if you would like to help. If you would like to make a new project, please do. So, my name is Marcus Jones, this is my Twitter. I'm also working at Ocean Protocol and looking forward to hacking with you. Thanks. Let's play this video too. I think we have some time. Yeah. Okay, so when I upload it to you, now it messes with the resolution completely, but this is the car driving. So it's overlaid with some information. So the current steering angle taken from, that's taken from this joystick, and it's taking the throttle back from this joystick. So that's being recorded on every frame, 20 hertz in this case. And on the bottom we see the actual current steering angle, and the red dot is the predicted steering angle. So the target steering angle for the AI. And then again, we have this saliency, which is what the network is currently paying attention to. So this orange highlight, we see actually a big issue here, which is that this glare spot coming from the reflection is actually influencing the prediction of the network, which is bad because the glare has nothing to do with the track. So this is a way that I was able to diagnose this issue, and I bought a polarizing filter, which sort of worked, but didn't really. But at least it points me in the right direction. Okay. Let's have some questions.
Okay. First questions. It can't be Dimitry.
Thanks for the mic. You mentioned at the beginning of your video that you were concerned by the overpopulation problem. How do you think that technology can help solve these sort of global concerns? Because in my opinion, this is sort of like the elephant in the room that we tend not to address and not to think enough about. Or we might think about it, but we simply don't talk about it. So yeah, what sort of system or idea you feel like how could technology help maybe solve some of that problem?
Well, I mean, overpopulation is, we have to sort of define that. So it means, let's say, exceeding a certain carrying capacity. So we have to first of all define what is that capacity and what quality of life are we willing to accept. So there's a point where, you know, we could all be living in huge apartment buildings, eating plant protein, and, you know, not having very cool, exciting lives, being able to travel, being able to consume like steak every night, you know what I mean? Like, it's really, you have to set a limit first. Or maybe not set a limit, but I mean, it's important. It's important to have that in mind. How to solve it? That's a good question.
Do you think we are already too many then?
I don't have any comment on that right now. I don't know. So I think what I'm definitely concerned. Let's put it that way. So this graph scares me. This climbing graph, simply because I've actually done a project in Africa, and I was traveling in these remote villages, and the birth rate there is 7 children per woman on average, and they don't have. They're on a subsistence type of life. So this means they harvest for this year, they don't save for next year so much. And combine that with this IPCC forecast, drought, and you have very, very serious issues. So how do we solve that? Yes, we put resources into that. We pay attention to it. That's a start, at least. Maybe we have some technological solution, but I think, honestly, it's going to take grassroots social change. So if you go to these remote villages in Africa, they don't care about AI or technology or the next coolest thing. They need medicine and education. So let's start there.
I've noticed the tendency tonight to focus on the consequences and not on the causes on the cause of the problem.
Which one?
In this case, making nature visible. So one of the, I'm working myself in sustainability and now building a venture on water measurements, water quality measurements in agriculture. I came to the conclusion that the problem lies in the invisibility of nature, and this is economic and cognitive invisibility. So we tend to address the consequences. Yeah, we tend to address, okay, there are too many people, what are we going to do? Why we don't go to the root of the problem? Why there are too many people? Why there is poverty? Why we go and design then systems for a better allocation of resources. But I think we go and keep on, administrating painkiller, and we don't ask ourselves why do we have these pains? Where are these pains coming from? After my in my work, I came to the conclusion that in the case of sustainability, in the case of human-nature relations, the root cause of the problem is nature's invisibility to people, and that there is different understandings of nature. Yeah? So nature is invisible in many ways, on many layers. So it's not a question, it's a comment. Here.
So causes.
Some causes.
So you think what is the cause again?
The invisibility.
The invisibility, and that causes the problems?
Yes. If I tell you we're gonna, there have been 10,000 hectares of forest cut in the Amazon.
Mm-hmm.
This is too abstract. We don't know what this 10,000 hectares of forest does. So this is cognitive invisibility.
Yeah, we're fighting for real estate in people's minds.
Right. And then economic invisibility. What are the economic consequences on short, medium, and long term of cutting 10,000 hectares of forest in a precise place in the Amazon? We have no idea. Can we model this? Can we make it visible? This would be
tangible to every person.
Yeah. This would be a first approach to trying to address the root cause of the problems if we keep on this linear logic, engineering logic of seeing the world.
Cool. May I have the microphone? Okay, I say thank you, Marcus. Have you watched this thing? He extra took it up. I think you should, I'm sure later.
All right.
We will cut off the live stream.
As we are turning down Berlin, yes. This is the end of us, and this is the end of tonight. This was the last talk. I would like to apologize for all the kind of sound that we had, and the little bit of issues, the bathroom kind of sounds and the reverberations. There will be a Tinder app on for the next few minutes for you to be able to still interact with each other, and there will be some real-life interactions possible afterwards also, thanks to some beers and pizzas still available. So thank you very much for coming tonight. Thank you very much for being here and giving us the energy to be able to do that. Thank you, Sid and Carsten and JP, for your talks and for being here. And thank you everybody for coming and for helping us doing that. You can give yourself a round of applause, and we will see you on the 12th of December. Take care.